Good day everyone. Now for this video, we are going to tackle about Lesson 11 Grouting under Chapter 4 Structural Geology and Rock Mechanics. What is grouting? Grouting in civil engineering refers to the injection of pumpable materials into a soil or rock formation to change its physical characteristics. It is one of the ways groundwater can be controlled during civil engineering works. History and development of grouting in civil engineering. Its traceable record can be as early as in the beginning of 1800s. In year 1802, the idea of improving the bearing capacity under a sluice by the injection of self-hardening cementitious slurry was first introduced. In year 1864, Peter Barlow patented a cylindrical one-piece tunnel shield which could fill the ambient void left by the tail of the shield with grout. It is the first recorded uses of cementitious grout in underground construction. In the year 1893, the first systematic grouting of rock in the USA was performed at the New Grouting Dam in New York. Later in the year 1960s, jet grouting technique was developed. In year 1977, at the Bolton Hill Tunnel, it was held the first application of compaction grouting for controlling ground movement during construction. And in the year 1995, the first industrial application of the compensation grouting concept was conducted at the construction site of the Jubilee Line Extension project in London. Now let's move on to the definition of a grout. Grout is a composite material used in construction to fill voids and seal openings in surfaces. It can also be defined as a solution, an emulsion, or suspension in water which will harden after a certain time interval. It can be divided into two main groups, namely the suspension grout and the liquid grout or solution grout. Suspension grout is a mixture of one or several inert materials like cement and clays suspended in a fluid, water. According to its dry matter content, it is either of the stable or unstable type. It is a mixture of pure cement with water. On the other hand, liquid grout or solution grout consists of chemical products in a solution or an emulsion form and their reagents. The most frequently used products in this liquid grout are solution silicate and certain resins. There are several known materials which can be used in grouting. So first we have the cement-based grouts. Cement-based grouts are the most frequently used in both water stopping and strengthening treatment. They are characterized by their water-cement ratio and their total dry matter or water-weight ratio. The properties and characteristics of these grouts vary according to the mixed proportions used. However, they have the following properties and characteristics in common. These properties include the stability and fluidity according to the dosage of the various components and their quality, unconfined compressive strength linked to water-cement ratio, the durability depending on the quantity and quality of the components, easy preparation and availability, the ease of use, and the relatively low-cost mixes. Another type of grouting material is the pure cement grout. Pure cement grout is an unstable grout. However, bleeding can be avoided with the water-cement ratio less than 0.6 to 7. Usual mixed proportions are from water-cement ratio 0.4 to 1 for grouting. Very high mechanical strength can be attained with this type of grout. Bentonite grout, on the other hand, is a stable grout. When bentonite is added to a cement suspension, the effects are: it may obtain a homogeneous skeletal mix with a wide range of viscosity, avoid cement sedimentation during grouting, decrease the setting time index in separation filtering processes, increase the cement binding time, improve the penetration in compact type soils, and obtain a wide range of mechanical strength values. In water stopping, grout will include a lot of bentonite and little cement. In consolidation works, grout will contain a lot of cement and little bentonite. Ideal mixes should be both stable and easy to pump. Another type of material is the grouts with fillers. Fillers are added in order to modify the viscosity of a given grout so as to obtain a low-cost product to substitute the cement. The most commonly used fillers are the natural sands and fly ash from thermal power stations. Grouts with fillers are used when water absorption and/or the size of voids are such that sealing becomes essential and when the leaking of grout into adjoining areas should be limited. In addition, fillers in grout will produce low slump grout with high viscosity for certain grouting purposes. Silicate-based grout. Silicate-based grouts are sodium silicate in liquid form diluted containing a reagent. Their viscosity changes with time to reach a solid state that is called the gel. They are used in soils with low permeability values such that all suspension grouts cannot penetrate. The soft gels. It is mainly for water stopping purpose. They are gels with a very low dosage of silicate in which the gelling process is most generally obtained by adding a mineral reagent. Now let's discuss the desirable characteristics of grout. Groutability. This expresses the ability of the grout to reach the desired location of the soil or the mass. To be able to do so, the grout should possess sufficiently high fluidity, and the suspended particles, if any, must be of a size that enables them to enter the void spaces in the soil mass. The stability. So it is the capacity of the grout to remain in a fluid state and not segregate into its separate components. We need the grout to be stable until it has reached its destination. Stability of clay cement grout is usually more than that of a cement grout. Third is the setting time. It is the time it takes before the grout sets into a cemented mass or gel. Early setting can cause difficulty in grout reaching its destination, and late setting can result in the grout being washed away if seepage is occurring through the soil. Additives are used to retard or accelerate the setting time as required. Fourth, permanence. It indicates the resistance the grout possesses against being displaced from the soil voids with time. Cement grouts have greater permanence than bentonite grouts, which can get washed away with time by seepage of water through the grouted zone. Toxicity. It is the capacity of the grout to contaminate the groundwater coming in contact with it and of adversely affecting the health of workers handling and injecting the grout into the soil. Now let's proceed to the application of grouting. Grouting is used in producing mass concrete structures and piles, fixing ground anchors for sheet pile walls, concrete pile walls, retaining walls and tunnels, repairing a ground underneath the formation of cracks and structural defects on building masonry or pavement. It can also be used in fixing the tendons and pre-stressed post-tension concrete, and filing the void between the lining and rock face in tunnel works. In this video, we are going to mention 4 methods. In drill hole method, a hole is drilled through the porous voids of the ground. Then grout is pumped via the grouting line into the surrounding ground of the section with the use of a single or double packers. Drill tool method. So it is a one-stage grouting method by means of the drill easing or rod. In the grout pipe method, grout pipes are installed in drilled hole for later on grouting injection operation. The gaps between the grout pipe and the drilled hole are normally sealed. When compared with above drill tool method, it is more flexible as the drilling plant is not engaged in the grouting operation. Finally, a different type of injection method, the jet grouting method or jetting method, is introduced in the 60s, which is a revolutionary change for the grouting concept so far. the grout with the aid of high-pressure cutting jets of water or cement grouting having a nozzle exit velocity of more than 100 meters per second and with air-shotted cut the soil around the threshold hole. Let's proceed to the different types of grouting mechanisms. First is the rock fissure grouting. Rock fissure grouting is the use of a hole drilled through the fissures in joints of a rock mass to allow grout to be injected at close centers vertically and re-injecting if necessary. Tube and manchettes or thumb grouting. Thumb grouting is the use of sleeved perforated pipes in grout holes, soils, or completely decomposed rock to allow grout to be injected at close centers vertically and re-injected if necessary. Compaction grouting. So it is a single-stage grouting with high-strength mortar to the ground to create a grout valve at the end of a drill pipe. Compensation grouting. It is a grout injection that can compensate or stress relief and associate ground settlement. Jet grouting. It is a grout injection that cuts and mixes the soil to be treated with cement or cementitious grout.